This is Programming Chapter 4, Part 2. We're going to look at more looping. First of all, we're going to write a program that prints the pattern below using nested loops. Nested loops are used in many algorithms, and we're going to look at one example. And it's important not to hard code your numbers. So let's take a look. Okay, as we see, here's a nested loop. You can think of y as the line number, and you can think of x as going across horizontally. And like I said, we want to avoid hard-coded numbers, so we've set 10 to this variable. And here we loop over this variable, which is set to 10. So let's run this. And we can see that it prints 10 asterisks this way, and it prints for 10 lines down. So it should be easy to modify our code to do this. And you're going to use nested loops for various exercises. Now, I did say that y was this way and x is this way. However, you might want to think of going down the screen as x and going across, this is down, and this is across, as y. So basically, we're rotating the printout from this direction to this direction, so we're turning it this way. And the reason why you want to do this is if we had our x and y axis like this, it's easier to think of a function for y. If we wanted to draw a triangle like this, then that would look like this, using our new axes. So if we still use our variables, this would be max, and this would be max, and here is 0, 0. So on the first line, y is equal to max. And if we think of this as a linear function, this is a slope of -1. So we have minus x plus max. So this is how far we draw each line. And we can switch this, x, x, y, x, and y. Okay, back to our formula. It's minus x plus max. So minus x plus max. Let's run this. Okay, now we see our triangle forming downwards, just like this. But again, we think of it rotated, having our x-axis be line numbers, and the y values is going across. So for this one should be straightforward. For this one, you might want to think of using the absolute value function. Here, again, we want to think of absolute value function. Here, this one's trickier, but I'll let you figure this one out on your own. And again, if you need help, please let me know. We don't want to use hard-coded numbers here. We want to use a single hard-coded number at the beginning, 1, maybe 2, and then have these as functions of max. And now that we've learned something more complicated, it's better to look at flowcharts again. For do while, we have a start, come in, we look at the statement. We check the condition, this is the while part. If it's true, we go back and do this statement. If it's false, we just fall out. For a while statement, we have a start, we check the condition. If it's false, we can stop. If it's true, we execute a statement, go back and check the condition. Again, if it's false, it goes to stop. Or if you have more statements, it will go to the next statement. And a for loop. So we have an initializer, we check the condition. If the condition is true, we go to do the statement. We do some kind of increment or decrement. And then we go back, and again, if it's false, we fall out of this loop and execute the next statement. Or just stop. And remember, for a for loop, this is optional, and this is optional, but we generally want to stick to this form if we're using a for loop, otherwise we'd be using a do while or a while loop. And one last thing, we want to talk about scope. Scope is always important. When we declare a variable inside the for loop, you can think of everything inside being part of that block statement. So this X will not exist after this for loop. So that's why if you look at other people's code, you'll see a for loop, they'll declare X, they'll have another for loop down here, and they'll declare X again, which is fine because they're separate X's. And this Y only exists in this for loop, so this X will not be able to see this Y. And that completes this lesson.